All right, guys, welcome back. Want to continue our conversation about the OSI model, but before I do that, there's just a few things that I want to hit because we need to understand some stuff. We've already talked about the fact that we have this model that we had in place. The first layer that we talked about was the physical layer. Now, the physical layer was where I complete my ones and zeros, where my interface information goes across. Components that I need to pay attention to here are going to be my cables, would be things like my network interface cards, repeaters, hubs, etc., etc. So, it should come as no surprise that this is going to be where the rubber hits the road as far as getting information from one host to another. Then we discussed layer 2. Now, the layer 2 we described as the data link layer. Now, the data link layer is important, and as I remember, we mentioned the fact that we have the MAC sublayer, and running on top of the MAC sublayer, I have the logical link control sublayer, the LLC layer. And they provide numerous functions for us. But there are some things that I want to make certain that we understand. Because when we start looking at this from the perspective of layer 2, the data link layer, there are some very important things that we want to make or need to make note of. And that is that the data link layer exists to provide the ability to communicate via node to node. And I'm going to go so far as to put an emphasis here. I'm going to grab my red pen here, and what I'm going to do is I'm going to say on the same segment. Now you'll remember I described this as an Ethernet segment. Now the reason that I defined that as an Ethernet segment is these devices are connected to one another and they are layer 2 adjacent. Now colloquially we could just use a term to say that they are on the same network. And I know I'm kind of putting the cart before the horse because we haven't talked about the advanced functionality that we described in the introductory module. But if these devices are on the same network, then I can actually communicate device to device at layer 2 utilizing the PDU that we call a frame. Because frames can be forwarded throughout my layer 2 infrastructure. Now, the problem here is this concept of node to node. This only works if we're in the same network or the same subnet. As an example, let's draw another configuration here. So I'm going to have 3 hosts. Those 3 hosts are going to be connected to a switch. So let's just say this is host 1, host 2, and host 3. They're connected to this switch via a single interface. Now this device that I have right here is going to be just a regular old-fashioned switch, nothing special to it. So we'll call it switch 1. Now, this switch is going to have interfaces. Let's just say 01, E02, E03, just to delineate and to name the interfaces. Now, the object here is that I'm going to go ahead and I'm going to assign these devices IP addresses. So let's pretend that this switch is running connectivity for the network 10.1.1.0/24. And we'll get into the details of this, but understand that host 1 is going to have the value of .1 in the 4th octet, so that's right here. This guy's going to have .2 and this guy will have .3. And they need to be able to communicate with each other. So what will end up happening here is that if I come into host 3 and I type ping 10.1.1.1, which is this guy right here, what I want to be able to do is I want to be able to send the communication from host 3 to host 1, and I want to be able to receive my replies. So ultimately I want to see 5 successful ICMP echo replies. Now the problem is this idea of ping actually is a protocol that runs at a higher layer than layer 2. It runs at the layer 3, which is referred to as the network layer. So just to illustrate this point, I'm going to come over here and I'm going to draw in the network layer. Now, the network layer is responsible, again, for configuration, but the network layer is going to be responsible for network to network communication. So layer 2 will allow me to be able to send information from host 3 to host 1, and I will be able to actually forward that via a frame, and it will have a source MAC address, the MAC address that's issued by the manufacturer of the computer or the network card in H3, and it's going to be destined to a destination MAC address, which is going to be the MAC address of this guy. So in this instance, let's just pretend that this guy has a MAC address of A.A.A. Now that's not the proper format, but it's just the way I'm representing it. B.B.B. When we get into switching, we'll get into all of the components. So H3 has a MAC address of B.B.B, and H1 has a MAC address of A.A.A. Now, I am saying I want to ping the IP address of .1. Now, the way this works is H3 needs to know the MAC address so that it can build this portion of the layer 2 header. I know the source MAC address, it's me, B.B.B. But I don't know the identity of A.A.A. We have a mechanism inside of the system that allows me to be able to take a MAC address or a burned-in address and discover it based on the IP address. So I'm going to take the IP address and I'm going to learn which host has that information through this process called ARP, Address Resolution Protocol. We'll see it in use when it comes time to do demos. But right now we're just talking about the basic operation. The reason being is that I have the IP, but I do not have the MAC, and I must have the MAC address to be able to form the layer 2 header. Remember, we talked about that encapsulation process. And this is going to work perfectly fine simply because H2, H1, and H3 are all part of the same Ethernet segment. But what if they're not? What if it was connected like this, where I had a device over here that is in 10.1.1.0/24, let's just say .1 is his IP address, and he is connected via some mechanism. In fact, what I'll do is I'll just draw in a cloud here, and let's say he's connected to or wants to communicate to another host, and that host is in a 192.168.1.0/24 network, and let's say he's got a .1. Well, the problem here is that these two devices are not inside the same layer 2 domain. They're not part of the same network. In fact, they are members of two separate networks, the 10.network and the 192.network. So what we need to do is we need a mechanism whereby we can communicate with these or between these two networks, and we do that in networking through the deployment of a construct called a router. And routers are devices that operate at layer 3. So devices that operate at layer 3 devices would be routers. Protocols that run at layer 3 would include protocols like ICMP, Internet Control Management Protocol. In other words, that ping was to an IP address. So that's going to be a layer 3 protocol. Other protocols that we're going to end up working with are going to be specifically IP. We can have IPv4, we can have IPv6 addresses. These are all components that we have to be worried about when it comes to this idea of networking. And remember, the network is going to hand that information down to the data link layer, but at the network layer, the PDU that we use is not called a frame, it is called a packet. So frames are forwarded, packets are routed. So, well, actually it would be best to say frames are layer 2 forwarded, packets are layer 3 forwarded, if we want to be as accurate as possible. Other protocols that I'm going to have to teach you guys about that you're going to want to know are going to include other layer 3 protocols. We are going to have protocols, we've already mentioned ICMP, we've got IPv4, IPv6, which are going to be addressing schemas that we can use. We also have protocols like OSPF, Open Shortest Path First, EIGRP, and we even have old school RIP. So when we start looking at this, these are routing protocols, dynamic routing protocols. So there's a lot for us to keep in track, there's a lot for us to monitor, and there's a lot for us to understand. And the interoperability between these layers, again, involves the encapsulation coming down from the access layer and de-encapsulation as I send information up to the other side. Remember, data link is going to be a node-to-node communication on the same network segment, because I can resolve reachability to destinations. But if I need to communicate between networks, I need to employ layer 3 network functionality through the creation of packets. And what I'm going to do is I'm going to usually use a routing device to be able to accomplish that task. So we're not going to start moving up a little bit higher in the configuration, where what we're going to do is we're going to be talking about the transport layer. Now, after the transport layer, I'm going to kind of bundle everything together until we have our conversations about the ACI, where we really need to understand, like I mentioned earlier, those layer 4 through layer 7 service capabilities. We're going to definitely cover layer 4, and we're going to talk about all of the other layers, but it's not going to be anywhere near as detailed as this. Remember that we had the configuration here where I have a protocol data unit that is referred to as a frame for Ethernet between the data link layers. Communication between the network layers employs a PDU called a packet. And then obviously we have to entertain what's going to be exchanged between the hosts at the transport layer. The transport layer can get kind of complicated for us, so we're going to spend a little bit of time on it because we want to talk about the difference between TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, and we'll do that in the next video. Until then, I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.